So hello everyone, and thank you, and welcome to another installment of the CODA webinar series where we discuss everything decommissioning. So my name is Rean Gilbert, and I'm the General Manager here at CODA, and I'm excited to be able to introduce Dr. Rachel Gavey and Nicola Morgan from Sustainable. Rachel and Nicola work with companies, investors, lenders, and insurers to translate climate, environmental, and ESG risks into clear, decision-ready insights. Today, they are going to talk to us about integrating carbon, costs, risks, and nature into decommissioning strategy. At the end of the presentation, we will have a Q&A, so please put your questions in the Q&A section of the chat, and I'll go through them after the presentation. So without further ado, I'd like to hand over to Rachel to take it from here, please. Thanks, Rachel.
Thank you. Good morning, everybody, or good afternoon, depending on where you are in the world. Fantastic to be here with the CODA team today for the webinar. As a brief introduction to what we do, my name's Dr. Rachel Gavey. I have a background in oil and gas exploration, and then in the last sort of 7 or 8 years with my co-founder, Rosalie Constable, we've been running Sustainable, really providing advice back into the industry. From a different angle this time, but from a place of really understanding the industry and the challenges that it faces. I'm joined today by Nicola Morgan, who's going to be doing the bulk of the talking today. Nicola also brings an oil and gas background, and I'll let her do an introduction when she starts. So the work that we do is right across the environmental, social governance space. Most of our team are in the United Kingdom. Nicola is down in Perth, where she's joining us today, and I split my time between the Middle East and the UK, and we're really working right across that whole space within sustainability. You can see here an example of some of our recent clients. So as you can tell, the majority are operators. We also work within the supply chain and service side as well, and we cover projects right across the world. The discussion today is going to be obviously very much focused on decommissioning, which is an area that we're very excited to be working in and supporting companies with. The bulk of the work that we do within our company is very much focused on the emission side, as you would expect from our industry. But what we're seeing now is much more of a requirement from lenders and regulators to really look much deeper than just emissions and the environmental side. So we're also very involved in things like supply chain management, wrapping everything up and ensuring that companies are really considering their risks. We do quite a lot of work in reporting and frameworks, which we know, for those of you joining us from Australia, I know a lot of you are, that's a big topic there. And we also do a lot around training and awareness. So I'll hand over to Nicola and let you do an introduction and present the slides today. Thank you.
Hi everybody, so my name is Nicola Morgan. As Rachel said, I'm a geoscientist by background, and I've been working with Sustainable now, working on greenhouse gas emissions, life cycle assessments, emissions accounting, and more general ESG type work. So by way of introduction to this webinar, everybody knows the decommissioning scale, cost and challenge that's presenting oil and gas companies globally. In the UK, where we have done quite a bit of our work, it's a mature landscape with large-scale removals underway, whereas Australia is more of an emerging market with the opportunity to adapt best practice. So the challenges aren't unique to either region. These projects are costly, they're emissions intensive, they're under increasing scrutiny from regulators and stakeholders. So what if the same analysis that helps you cut emissions could also help you to cut costs and reduce project risk? We'll show our case study assessments throughout this webinar and aim to demonstrate emissions forecasting as a decision-making tool and not just as part of an ESG report. I'll show how incorporating greenhouse gas emissions forecasting can change the way we plan decommissioning, linking carbon directly to cost and programme duration, and turning it into that decision-making tool rather than a reporting metric. We'll go through our case study, which is 2 normally unmanned installations, the associated platform wells, which are 20, subsea wells, there's 1, and pipelines 55 kilometres. It's based in the North Sea. And the 2 scenarios that we will speak about are one on the infrastructure removal, whether it's full removal, partial removal, or leave-in-situ, and one around different scenarios for well P&A, rig-based, rigless, and hybrid options. So why is decommissioning planning important? It's no longer just an engineering or a cost problem. Decommissioning decisions are getting harder, there's more stakeholders involved, there's more scrutiny, there's more competing drivers. So operators are balancing emissions, biodiversity, health and safety exposure, increasing regulatory scrutiny, and all at the same time. So the question's now no longer what's the cheapest option, it's changed to what's the best overall decision across multiple competing factors. So today we'll try and show how these competing factors are connected, and how a comparative assessment approach allows you to quantify those trade-offs to make more robust, defensible decisions. So this slide shows how the 4 key drivers connect. At the centre of them all, there's operational activity and programme design. So that's things like vessel time, fuel use, logistics, programme duration. The emissions, they're driven by fuel and activity. The cost, they're driven by duration and logistics. Health and safety is driven by the exposure time and the programme length. And then biodiversity is driven by the disturbance of removing these structures. So when you change one part of the programme, you're affecting all or more than one of the other drivers. In some cases, these things will align, so shorter programmes might reduce your emissions, your cost and your exposure. But then in other cases, they might not align, so reducing disturbance may conflict with removal requirements, and then the lowest cost option might not be the most defensible. So this is not about optimising one variable, it's about understanding how they interact and trying to make a balanced decision. So this is a client project where our approach came from. The requirement of this project was not just to calculate emissions, but to understand what was driving them. As part of this work, we developed a tool aligned with the OEUK work breakdown structure to forecast emissions across decommissioning activities. So we found that emissions act as a proxy for operational intensity, programme length, vessel time, fuel use. So rather than just being a reporting metric, it can start to give you insight as to how the programme is designed and executed. And that's what's allowing it to become a decision-making tool. So our methodology is grounded in the OEUK work breakdown structure, and it's aligned with the Greenhouse Gas Protocol and ISO 14064. The OEUK work breakdown structure is industry standard breakdown of decommissioning activities for cost planning, and it's widely used throughout the industry. What it does is it provides a standardised framework of 11 categories for organising and detailing the full scope of decommissioning activities, and that will allow for consistent planning and reporting across projects. This approach has been applied by us across multiple North Sea case studies using our sustainable tool. That's important because it ensures when we compare scenarios, we're comparing like for like. So each phase of the decommissioning programme is captured in a consistent way, from well decommissioning through to topside, subsea and site remediation. It gives a structured foundation for both emissions forecasting and cost comparison. And it's this consistency then that allows us to quantify the differences between scenarios and help to support comparative assessments. So how was the analysis performed? We estimate emissions at each stage of the decommissioning programme using detailed activity data. So things like vessel type, fuel consumption, campaign duration, well counts, pipeline length, distance of assets to shore. We apply standard emissions factors and convert everything to CO2 equivalent using the IPCC global warming potentials. The costs are derived from UK benchmark data sets. They can also be adapted to specific company or regional data sets. So costs and emissions can be compared on a like-for-like basis. The key point is that we focus on the relative differences between the scenarios and not absolute numbers. And then our model is built in Excel, which allows us to test different scenarios quickly and consistently. And then we can change things like technologies, schedules, and different operational assumptions. So we applied this thinking to a real North Sea asset by way of a case study. It consisted of 2 normally unmanned installations connected by subsea infrastructure. And there's 55 kilometres of pipelines and 20 platform wells and 1 subsea well. So the 2 different comparative assessment cases that were examined, one was for infrastructure remover, which covered the full scope of work breakdown structure 1 right through to 11. The other case study focused on the well P&A strategy, which was work breakdown structure 3. So for each of the scenarios, they represent fundamentally different decisions, not just technically, but in terms of what you're optimizing. So each option changes the balance between disturbance, cost, operational intensity, and the program exposure. And importantly, each of these then links back to the carbon, the cost, the safety, and the environmental impact. So when we compare scenarios, we're not just comparing engineering approaches, we're comparing the different trade-offs. And that's what makes this a decision problem rather than just a technical one. So in this scenario, we've defined 3 decommissioning, the 3 decommissioning infrastructure removal scenarios that were assessed. So we started off with the full removal. So this is the traditional approach, and it's typically the regulatory default, so that all infrastructure is removed from the seabed. The partial removal scenario removes the topsides and the jackets, but leaves the pipelines in place. And then the leave-in-situ case are the topsides and most of the jackets are removed, but the jacket footings and the pipelines remain. The 55-metre clearance here relates to the navigational safety requirements. And what's important in each of these scenarios is what it represents a different level of intervention. And that directly drives the differences in emissions. So you can see here the full removal at 64,000 tonnes of CO2e versus the leave-in-situ with a reduction of 30,000 tonnes of CO2e. It also drives a difference in the duration of the programme. So the programme will be shorter if you don't have to remove all the infrastructure. You'll reduce the seabed disturbance if you leave some of the infrastructure in place. It will have an impact on your cost, but ultimately also the regulatory acceptance. So again, we're not just comparing technical options, we're comparing the different trade-offs between these different drivers. Each option here will change the balance between the emissions, the cost, the risk, and then the environmental impact. So biodiversity considerations. Biodiversity, it's a key consideration in decommissioning decisions. The removal of structures, pipelines and mattresses can result in seabed disturbance and habitat loss, particularly where the species have colonised infrastructure over a long period. There's also operational impacts during execution, including noise, vessel activity, and discharges, which can affect marine mammals, fish spawning and migration, and overall water quality. So decommissioning decisions directly influence marine ecosystem outcomes. And then this is where a balance is required between regulatory compliance, cost, emissions, and long-term biodiversity impact. At a simple level, removal leads to seabed disturbance, while leaving the infrastructure in place can support habitat retention, but then that introduces longer-term considerations around ownership and liability. So in terms of Australia, should Australia assess decommissioning on a case-by-case basis on its own merits? Because in some situations, leaving stable, colonised infrastructure in place may preserve habitat and deliver better environmental outcomes than a blanket clear seabed approach. The legal point is that any shift towards that partial removal or in situ retention would have to have clearer rules around it, so you can reduce that uncertainty for operators. There's no single best environmental option, only different impacts that need to be balanced. So this slide shows the results of those 3 different scenarios. It shows the comparison of emissions and costs. And starting with the full removal, it's clearly the highest emissions and the highest cost option. If you move to partial removal, we can see a significant reduction, around 40% reduction in emissions, and a similar reduction in cost. And then with the leave-in-situ, there's a further reduction. What's driving these differences? It comes down to time, vessel usage, logistics, particularly around transport and disposal. In the base case, more vessel days, more fuel, more transport, all directly increase both emissions and costs. And this is where the decisions need to be made across these 4 drivers. It's no longer about selecting a lowest cost option, a lowest emission option in isolation. It's about balancing that carbon consequence and cost in what is a defensible and transparent way. One important insight from this case study is that the pipeline removal for this particular asset accounts for a large proportion of the emissions. So seeing if you can target these key activities could deliver significant reductions. And now we'll move on to our next case study. We want to show why well plug and abandonment in this case deserves particular attention within decommissioning. If we go back to the OEUK work breakdown structure, the well P&A occurs very early in the decommissioning sequence, but it often can become the longest duration phase of the entire programme. And there's a few reasons for that. The P&A is highly energy intensive. It involves drilling rigs or dynamically positioned vessels, both with high diesel consumption. It also involves extended offshore exposure, multiple wells, and often there's things like non-productive time and weather-related downtime. So these activities tend to be rig heavy, fuel heavy, and time intensive, which means that they can quietly become one of the most emissions intensive parts of the decommissioning programme. What we found, though, is in many projects, emissions are only quantified after the strategy has already been selected, if at all, rather than being used to inform the strategy itself. And that's really the motivation for this case study, to explore how emissions forecasting can be brought upstream into the planning process alongside cost and operational considerations. So here we define the decommissioning scenarios for the well P&A. What actually is driving the emissions reduction in well P&A? Is it technology substitution, such as rig versus rigless methods? Is it program design and sequencing? So to try to answer this, scenario 1 establishes the baseline. That is a conventional rig-based campaign. It gives us the overall footprint for emissions, for rig fuel exposure, and for the campaign duration. In scenario 2, it introduces a rigless intervention for eligible wells, reducing the rig days, and therefore reducing fuel consumption and cost, and the overall programme duration. And then finally, scenario 3, it keeps the same technology, but it optimizes the campaign sequencing by having them run concurrently. And that isolates the program design then as a measurable emissions lever. So the model assumes that well selection is screened based on integrity, access, and barrier requirements. So rigless is not just applied universally. And then the intention with this is not to suggest that rigless is always a solution, but to quantify how reducing rig days can influence the overall emissions and cost outcomes. So with this case, it highlights the health and safety benefits of optimizing decommissioning programs. As the program duration reduces, so does your offshore exposure. Fewer vessel days will mean fewer personnel offshore, fewer simultaneous operations, and that can all contribute to lowering the overall risk. Optimizing scheduling and reducing rig days, it not only improves efficiency, it can directly reduce the cumulative HSE exposure. So in this case, we see a strong alignment. Reducing emissions through shorter programs also reduces the safety exposure. And this is the important point with this scenario. This is one area where improvements in carbon, cost and safety can be achieved together. So with the results for this comparative assessment, the slide compares the emissions and cost outcomes across the 3 P&A scenarios. The rig-based campaign establishes the baseline, both in terms of emissions and overall project cost. Introducing rigless intervention for eligible wells reduces the rig exposure and fuel consumption, resulting in material reduction in both emissions and costs. And when the programme is further optimised through improved sequencing, we can see additional reductions driven primarily by the shorter campaign duration and fewer days. In this case study, optimising the P&A by having the rig and rigless P&A happening concurrently reduced the programme length by almost 12 months. So the overall analysis shows an up to 18% reduction in emissions and around 17% reduction in P&A costs. What this highlights is that the biggest drivers are the rig days, the fuel consumption and the offshore exposure. So both technology substitution along with programme optimisation can deliver environmental and commercial benefits. In practical terms, every rig day avoided reduces both diesel burned and the cost exposure. So that's why these two metrics track so closely. And importantly, as the campaign duration reduces, in this case by up to almost 12 months, we would also see a reduction in emissions cost and therefore the HSE exposure. So now I'll go into an overview of the tool that we use to carry out these assessments. So this is a snapshot of our emissions forecasting tool. As I mentioned, it's structured around the decommissioning workflow and aligned to the OEUK work breakdown structures. The users can input activity-based data, so things like vessel type, like fuel use, like campaign duration and logistics. And a key point is that everything is built around real operational inputs, not just high-level assumptions. And that's what allows us to generate credible scenario-based outputs that can be useful for decision-making. This slide shows a more detailed view of work breakdown structure 3 and the underlying data within the tool. At this level, we're capturing key inputs and assumptions that drive both emissions and costs, things like vessel activity, things like duration, logistics, supporting operations. The important point here is that all the assumptions are transparent and structured and everything's clearly defined, documented and consistent across the different scenarios. So that means when we compare options, we're not just comparing the outputs, we're comparing the decisions based on the same underlying framework. And that can help give us some confidence in the results, particularly when the outputs are being used to support regulatory submissions and internal decision making. This is also where we can stress test assumptions and run sensitivities, for example, around vessel days, fuel use and campaign duration. And on this slide, you can see inputs such as taking account of non-productive time, waiting on weather, total number of wells, mob and demob days. So on this slide, we can see the emissions output. So these are broken down by activity, by asset, and by work breakdown structure. This allows us to identify where the emissions are coming from, not just the total number. We can really start to drill down and see what areas of the decommissioning programme are responsible for the highest emissions. That really enables us to have targeted optimization so we can focus on those highest impact activities. And this slide shows the cost outputs for the tool. Similar to the emissions, the costs are broken down by activity, by asset, and by work breakdown structure. This allows us to see not just the total cost, but where the costs are being driven within the programme. So we can identify the highest cost activities, such as vessel time, lifting operations, logistics, waste handling. And because the cost model is aligned to the same activity data as the emissions, we can compare cost and carbon on a like-for-like basis across the different scenarios. And this is where the tool becomes quite powerful. We can start to see where costs and emissions align and where they don't, and make more informed decisions as a result. It also enables benchmarking, for example, looking at emissions intensity per dollar spent or identifying high cost, high emission hotspots for optimization. So we're not just reducing emissions, we're understanding the cost implications at the same time. This slide shows how we can incorporate uncertainty into our tool. Rather than producing a single number, the tool allows us to model a range of outcomes using probabilistic analysis. We can generate P10, P50 and P90 results for both emissions and costs, and a range of the model inputs, giving us a clearer view of the potential variability across the project. We also identify the key drivers through sensitivity analysis, identifying which inputs have the greatest influence on the outcomes. So things like vessel days, P&A duration, weather downtime can all be tested and understood. And this is important because it moves us beyond a point of estimates to a better understanding of risk and uncertainty in the programme. And in practical terms, these would help support planning, decision-making and regulatory submissions. And ultimately what that does is it allows decisions to be made with greater confidence, transparency and defensibility, really. So we're not just modelling the outcomes, we're quantifying uncertainty and risk around them. And it's this combination of emissions, costs and uncertainty that feeds directly into the comparative assessments that we've been working on. So how do these drivers connect? Hopefully in this slide, we'll try to bring everything together across both case studies. What we've shown is across infrastructure removal and the P&A strategy, these drivers are not independent. They're all linked through what operational choices that you make. Emissions are not just something we report, they're a proxy for operational intensity. More vessel time, more fuel, more activity means higher emissions, higher costs, longer exposure. Health and safety is directly linked to exposure, and exposure is driven by schedule. So anything that reduces the programme duration reduces both risk and emissions. Biodiversity. That's fundamentally about the seabed disturbance. Removal increases the seabed disturbance while retention reduces it. But that does introduce longer term liability considerations. And then the cost, that's driven by duration and logistics, which is why it often tracks so closely with emissions, but not always. So in some cases, things align nicely. Reduction in time, reduction in emissions, reduction in risk, reduction in cost. That's great. But that's not always the case. A lower carbon option may require different vessels or approaches. Reducing your seabed disturbance may conflict with your removal expectations. And the lowest cost option may not be the most defensible. This is why decommissioning becomes a real decision problem. It's no longer about selecting the lowest cost or the lowest emission option in isolation. It's about balancing the carbon, the consequence and the cost in a way that's transparent, defensible and aligned with regulatory expectations. So what does all this mean for Australia? Australia has committed to a 62 to 70% reduction in emissions by 2035. That's a really significant target, and the oil and gas sector will be expected to contribute. So every major project will be under increasing scrutiny. And while the regulatory starting point is still full removal, the door is open for alternative approaches, provided they can demonstrate equal or better environmental outcomes. And that's where this tool and approach can become powerful. We've seen in the case studies that there can be a material reduction in emissions, which is the climate impact and cost, particularly when the decisions are supported by this evidence and linked across multiple impact areas. Regulators and communities are not just looking for the cheapest solution, they're looking for outcomes that genuinely minimise the overall impact. And that means moving beyond single metric decisions towards a more integrated, evidence-based approach. By adopting emissions forecasting early in the planning process, Australian operators can align with the net zero trajectory. They can strengthen regulatory submissions, and they can make better and more defensible decisions. There's a real opportunity to shape how this becomes standard practice in Australia. So, just to leave you with some final thoughts, decommissioning is no longer about just removing infrastructure. It's about making decisions across multiple competing drivers. What we've shown today is that emissions are not just something we report on. They're a powerful way to understand how a programme is designed and how it performs. When you bring emissions into decision-making process early, alongside cost, safety, and environmental considerations, you can unlock informed, balanced, and defensible decisions. And importantly, you can quantify and justify those trade-offs. And that's becoming critical in a more scrutinised regulatory environment. So the opportunity is clear to make emissions forecasting part of the upstream, make it a standard part of how we plan and deliver our decommissioning, because there's no single best option. It's only better, more informed and more defensible decisions. And I think what gets measured gets managed. So in decommissioning, it would be good to start measuring emissions. I'd like to say thank you to my colleagues, Rachel and Rosalie. And thanks also to CODA for inviting us to speak at the webinar and to share our work. And I would be delighted to take any questions.
Thank you so much, Nicola and Rachel. That was fantastic and very interesting, and no doubt very relevant to many of the people here today, be it Norway, the UK. We had a little bit of an exchange there while you were talking about where we're all from. So we had Norway, we had Australia, we had Brazil, and also the UK. So obviously, how to reduce emissions and save costs. How can that not be of interest to everyone in this room today? So guys, don't be shy. Please put your questions in the Q&A. It's a relatively smallish group. So if you have any questions, please do shoot them through and I'll read them out. So Nicola, if you don't mind, I'll start with my question. I'm fortunate. I've seen the tool in action. I'm a big fan, and you know that. I think the tool will be of great interest to many people here today and operators in their decommissioning planning going forward. So I guess what I'd be interested in is how long would it take you to apply this forecasting method to a typical project? And what other types of comparative assessments do you think could benefit from this emission forecasting approach?
Okay, thanks, Regan. So on the first one, how long does it take to apply the forecasting method? So I'm going to say it'll depend on the asset and the breakdown of assets. But initial assessments can probably be done quite quickly. So depending on how much data you have, they can be done in a number of weeks. So the framework's designed to be lightweight but scalable. So it can evolve as the project detail increases. So if you started at the very start of your planning, it might take only 1, 2, or 3 weeks to put something quite high level together. And then as the engineering design closes in, as you get more data, you can update that framework, that high level framework that you've got to evolve as the decommissioning planning progresses. So that was the first one. And then what other types of comparative assessments? So many different types. So we've showed the infrastructure scenario assessment, we've showed the P&A. You can do it for things like early versus deferred decommissioning. So what happens if you decommission now rather than waiting a number of years and holding off on decommissioning? So you can access how that timing affects emissions intensity, costs, aging assets, might carry a higher HSE risk. You'd have difficulty increasing to dismantle them. It might extend your campaign length, so that might be another good scenario assessment. You could do it for things like contractor or vessel selection. So a low emissions vessel versus a higher emissions vessel, and what the impact is and what's the cost of one versus the cost of another. Another interesting one would be around waste handling methods. So things like recycling versus landfill, local versus transport, international. Could also look at things like post-COP power options. So what happens if you you could power your site with your produced gas, or what happens if you have to power it with diesel generators? What's the difference there? So many different comparative assessments. Anything that you'd like to compare, the tool can assess.
So basically, it can pretty much compare whatever you want.
Whatever you want, yes.
It's applicable to anything. So we do have some questions. Thank you, Louise. She said it was a very interesting presentation. Are you able to copy the link? It looks like your colleague Rosalie has already done that, so the link's already there. Victoria says, looking at recent projects, what are the key lessons that didn't go according to plan, and how have those changed your approach?
That's a good question. I think something that drives us is that I don't know of a single emission or decommissioning project that has come in on budget or on time.
Everything has uncertainties, right?
Exactly. And I do think by bringing some of this planning in early and doing a lot more of it ahead of time, it can't be a bad thing, especially linking the activity with the cost. And that's not to say that, something can happen or something unforeseen can happen, because there are so many uncertainties. But including something like our uncertainty analysis section in the tool, you can start to give yourself a range of outcomes, so that you might say, well, what happens if my P&A goes this much over schedule, this much over budget? Can I get a P90 range for what my emissions, cost and schedule are going to be? Can I get a P10 range? Can I get something that I hope it's going to be around P50? So you can start to incorporate that uncertainty and help your projects maybe not go over time and over budget, and stop some of those surprises. So that's what we would hope that you could learn from decommissioning projects that have happened already, and hope that you can plan better going forward.
Yeah, great.
And if I can jump in on that as well, in some recent projects that we've done in the North Sea, what we found that we go through things in a different way, and we're looking at things through a different lens, and we've been able to pick up on bits of data and bits of planning that maybe were missed looking at it through other lenses. And so maybe we could see in one example, we're like, well, that's sort of a spike in emissions. Why have they got a spike in emissions? Like, what's going on here? And so it's almost like providing another sort of QC process to go through the planning as well. And we know that provided quite a lot of help and feedback with that project, where we were able to say, we're not sure why we're getting this slightly strange result, and it turned out that there was an error in some of the planning that had gone in, just an oversight. But it helps to kind of to provide that extra layer of QC through a very different lens as well, that people don't always look at it through.
Yeah, great. Thank you, Rachel. We have a question here. It says, how does this integrated strategy influence governance and approval processes? Or how could it influence governance and approval processes?
Well, we're hoping that it can. So how could it? You're showing more evidence-based and science-based information, and you've calculated the emissions and the activity around what it is that you're doing. So for something like biodiversity, it can be quite difficult to actually calculate and quantify that, to show it in a report for a regulator to make a decision, because we don't know what's going to happen in 100 years, or it is quite difficult to calculate. Whereas the emissions, which are under increasing scrutiny, and we've all got to reduce emissions for 2035 and 2050, emissions are something that you can actually quantify, and you can show today in real terms what these differences in approaches would equate to in terms of your emissions. So that's why we think it would be quite a nice tool to go along with some of the other evidence-based comparative assessment work that gets submitted for approvals. The other thing that I think is quite good with this tool as well is that often in bigger companies, the people making decisions about the well P&A won't be sitting together with the people who are making decisions about the waste handling or about the cleaning and flushing of the pipes. So having this tool here, it can be an oversight and bring together all the information into one place that can be spread across different departments or different countries or different office locations. So it really is a sort of integrated overview as well. So hopefully that it can be a place where all the relevant information can get incorporated, and that can be useful then for submissions as well, because everybody's talking to one another by using the tool to populate their different the different sections.
And I think that's where the dashboards come in particularly useful as well, when we're talking about strategy and when we're talking about that integrated thinking, to have the dashboards that Nicola showed, you can change things, you can see the different scenarios that come out of it. So companies are able to really think about that strategy and tweaking different things in a really nice visual way that can be presented for communication to exec team, boards, and other relevant stakeholders as well involved in the process.
Yeah, great. Thank you. If anyone has any more questions, please put them in the Q&A. Douglas William was very complimentary of your presentation and your tool, so I'll leave that for you to read afterwards. I do have another question. You've spoken about the North Sea. Obviously, you've got quite a lot of experience and data available for the North Sea. Is your tool easily adaptable to Australian conditions?
Yes. So that framework itself it's fully transferable. So specific things like the costs and the operational assumptions, they will vary basin to basin, country to country, maybe even operator to operator. But the principle of linking the emissions activity data and comparing those alternative strategies, that remains the same. So like absolute numbers will change with local vessel fleets or fuel factors or things like that, but the approach remains the same and is transferable for Australia. Yes.
And Brazil and Norway and pretty much anywhere.
And worldwide, yes.
And it's obviously very much dependent on the assumptions that you're putting in. How sensitive are your results to those assumptions?
So the relative differences between the scenarios are probably more important than the absolute numbers, because it is a forecast. But because they were applied across all scenarios, those comparisons kind of remain robust. So it's the same assumptions that go into each of them, with just that one factor adjusted depending on what scenario that it is you're testing. And then the slide I showed around the sensitivity functionality in the tool. So that will also be a tool that can be used to run to test sensitivities as well. So we can run that Monte Carlo simulation on key sensitivities. So it could be the well P&A duration, it could be the weather downtime, it could be the non-productive time, and you can test how sensitive your model is to those different inputs.
Yeah, good. Okay. Louise has asked a follow-up question to the question that I asked earlier, which is very valid. She says, what kind of data should we be looking for in Australia to do that adaptation, with your tool?
So I think that using the OEUK work breakdown structure is a good framework, because those 11 different subcategories mean that you can be confident that you've captured all of the activities relating to every single section across the entire life cycle of your decommissioning project. So that's quite a nice framework. Data that would be useful would be things like, are there Australian databases for emissions factors for your fuel and your transport and your different types of vehicles, helicopters, support vessels, rigs? So for the North Sea, there's a UK government database that has emissions factors that would be relevant to that. So if there was an Australian equivalent, that would be good data to look for. Other things would be, if you wanted to link the costs, would be around what would be local day rates for each of those different rig options. When you talk about your waste handling as well. So the waste story will be quite different in the North Sea versus Australia, because in Australia, you'll probably have to take into consideration huge transport distances where you might not have to take that into consideration for the North Sea. So there will be things that will be specific to particular local areas. But if you can try to quantify your activity, you've got your emissions factors that are relevant, and you've got a relevant cost. They're the three pieces that you really need to do the calculation.
Yeah. Okay. I mean, I know waste obviously is very topical at the moment in Australia. Everyone's trying to figure out what to do with their decommissioned assets when they come back on shore. So personally, I'm going to be knocking on your door again for another webinar, one that focuses on waste. I am going to call it to a close today. Thank you so much, everyone. Thank you, Nicola and Rachel, firstly. And thank you, everyone, for coming from Brazil, from the UK, from Australia, from Norway. Thank you so much to our international audience today here. And I hope to see you again at the next webinar. So thank you, everyone.